Hello everybody, this is lecture 6 of the Electronic Devices Electronics 1 course. I am Amar Abdulbari with Nearest University. Today I will speak about the circuits of the BJT amplifiers. Let's indicate something before we start. Here we have the VCE lowercase or subscribe italic case. This is for the AC quantity. So if it is at uppercase or a capital letters, it is for the DC. For the AC, it is lowercase and italic. Okay, for that's it. To remember and to differentiate between the DC and AC. Now the linear amplifier should giving an input with something like this and having an output. It's amplified by a value, by a gain. Okay, as you see here, it is the same replica but reversed. So it's reversed and inverted between the input and the output. So the AC load line is different from the DC load line because here, as you see here, there is a capacitance. The capacitance, the DC, it's seeing at end of the circuit. However, for the AC, it's crossing this capacitance, and so the capacitance in the AC, it's seeing the load resistance and the source resistance. Okay, so here that's what I say. Transistor AC model. The model here for the AC, it's seeing some resistance here inside the a small resistance inside the circuit, or an equivalent inside the transistor, or equivalent circuit. So we name it as R parameters. Okay, so we have to take it into account or calculate it for all the resistance inside or around the circuit. So you make it equivalent or a model. As you see, source of the voltage or the current and a total resistance of the circuit. So this is the base emitter collector. Okay, now the RE dash here is equal to 25 millivolt over the IE, the current here in the IE in the emitter. Okay, so this is, you see it is this equation, you use it to calculate RE dash. Okay, an important RE parameter or R parameter, we take it into account when which is AC, small AC resistance. So we take it into account when we calculate or analyze the circuit from the AC perspective. Now the common emitter amplifier, there is a multiple or a family of the amplifiers. We have here, we start with the common emitter. Common emitter meaning that we have the emitter as common. So the base here, it take the input at the base, at the P here, and you take the output as at the collector. So the emitter is common for both of them, for the input and the output. Okay, that's the meaning of common, because later you see common collector or common base. Okay, so you take the input and the output from the other two terminals, okay, of the transistor. Okay, here you see that in this circuit, in the common emitter amplifier, you see that I input the signal, and you take it as inverted, amplified, and inverted at the output. Okay, now let's see what is the RE dash for the CE here. So I take the calculation before. So VBE here as here VBE, the voltage, I have to calculate the IE, the current at the emitter. So VBE here in this point is R1. It's using he said assume the voltage divider. If you remember voltage divider, why it's moving like this? Yes, assume the voltage divider. So you calculate the voltage divider as R2 over R1 plus R2 multiplied by the VCC. You have the number for the VB, then you subtract 0.7 from the VB to get the VE voltage here. Then you have a resistance here to get the IE, the current in the emitter. Then you use the previously equation for the RE dash to calculate it, 25 millivolt over the RE over the IE to get the RE dash here. Okay, now let's see another example. Note that the AC resistance of the collector, as I said before, at the AC analysis, the collector, the C here is it's not shown. So the current, the AC current, is go through the capacitance and reach the load. So the collector doesn't only see the RC, it see the RC plus the RL or and RL, so it see it as parallel to each other. Okay, so the solution here, the V output, the gain, he asked for the gain of any amplifier is the voltage at the output over the voltage at the input, or the power. Okay, so the AV, the amplifier gain, is voltage V output over V input. So you divide the resistance at the output, all the C here, the output, what is he seeing in the output, over the resistance at the input here, what is the resistance that see it in the input here. So at the output is RC parallel with RL, and at the input he see the RE dash. Okay, this is the AV. Now the gain will be little lower if the input load is taken into account, if there is a load here. Okay, now here the common emitter to gain more stability. You see here the circuit, we make some changes to gain some benefits, so it's not static. So it's not you memorize a shape for the circuit and that's it. No, there is changes that maybe happen to the circuit, or addition, or you remove something to gain something. So you have to understand and take into account that calculation may be changed from one circuit to another. Okay, now they put here RE1 here, which calling swapping resistor. He put it into the emitter circuit, so to achieve more stability in the gain. Okay, what is the gain now? If you ignore the small effect of the RE dash, then AV is equal to V output over V input. V output is RC parallel with RL over RE dash here plus the RE1 here. Okay, why you didn't take RE2? Because there is a connection to the ground here, so you can't see it's not taken into account. So if you take the calculation, it's very easy to take the gain. Now if you make this circuit into the multi-sim software, simulation software, you see that this is the input and this is the output. It's reversed, but with a gain, it's amplified with a gain. Now the common emitter here, In addition to gain stability, swapping having the advantage of increasing the AC input resistance. So for this amplifier, the R input is given by R1, R2 parallel with beta multiplied by RE dash plus RE1. Okay, so the gain will be different this time. So we calculate the R input. What is the resistance that the input here see it? He see all this. So you take the parallel R1, R2 beta multiplied by RE dash plus RE1. This is as a one circuit that's in parallel with R2 and in parallel with R1. Okay. Now the common collector, another circuit, we take all here as a common emitter. The common collector is the main characteristic of the common collector. It's that you have the input at the base and you take the output at the emitter, and the gain is almost 1. So you don't see any higher gain or a high. The circuit is almost the input is almost replicated in the output, but you have here high input impedance in here, and the current gain is higher. Okay, so the output is taken from the emitter, so the collector is common for each of both of them. Okay, now I take power gain, as I have here the voltage gain is the same. So the power gain here is delivered to the input resistance divided by the power dissipated in the load here. So the AB is equal to the power in the load over the power in the input. So it is VL square, the voltage here dissipated, over the RL multiplied by the V input over the R input, what is seen in the R input here. So you take it as V input V output over V input. It is AV square, okay, multiplied by the R input over the RL. This is will go in the numerator, and this is will down to the denominator. This is, we assume it as 1 because here it's the voltage gain is equal to 1. So what is lifted is a calculation of the resistance here. So here he say that the AV is 1, beta is 200, beta AC. Remember that there is a difference between beta AC and beta DC. Use the RE dash as 2. So calculate the R input as R1 parallel to R2 parallel to here. You see that the input seeing the RE dash plus not only RE, but there is also RL, because you take the input here in this side. Okay, so you see it from the input from here until you take it to the ground. Okay, so this, all of this. Okay, now this is the R input. The RL is only the RL, there is nothing here. Okay, now the AV is R input over RL, so the AV is this number. The common collector is not rock solid. Why? What's meaning by rock solid? So it's a changeable. The voltage divider not always the best design for the common collector, because let's see here, if we calculate again the R input, but if you see here the difference is you change the resistance here. The R is 4.96 kilo ohm and the RL is 10. So the AB is less than 1. So this is not, again, you have a problem with the circuit here. So RL normally is the load, load may be changed, but here the design of the circuit should be solid, should be giving the gain despite of what's happening. Okay, so this design inside is affecting the gain. Another circuit is called Darlington pair using two transistors instead of one. Previously we use one in the common collector and the common emitter. Here we have a super beta, and Darlington is available in one package. It's usually in amplify the load. Amplifier, you can see it in the speaker as you speak in the microphone, and you hear your voice louder than higher by a very large number than the volume of your voice. So cycli pair is another beta pair. This is here you see two transistors, but in Darlington you see two transistors in the same PNP junction, NPN junction. Here you have two, one is NPN junction and one is BNP junction, so it's connected from the emitter here, it connected to the base. Now, so what is the relation between IE2 here, the IE2, and IB1, this one? So if you see here, IC1, this is IC here, is equal to beta IB, and here as you see the IC1 is equal to beta DC IB1. This is for the first transistor, the BNB transistor, and it is equal to IB2. So you have IB2 here. You need IE2. IE2 is approximately equal to IC2, which is equal to beta DC multiplied by IC1. Okay, so the IE2 related to IB1 is equal to the beta multiplied by each other. Okay, beta for the first transistor and the second transistor. Now the CB, common base. Now common base meaning that I input the signal to the emitter and I take it from the collector, and the base is connected to the ground. This is an advantage in the higher frequency. Okay, the purpose of the C2 is for make sure that in the AC analysis, when you apply an AC signal, the base is zero here, connected to the ground. Okay, multi-stage amplifier, another amplifier and design. You have a multi-stage, you have the first stage, second stage, so you have higher gain, and the input here and the output are capacitively coupled. Differential amplifier, this differential amplifier is commonly used as the input to the operational amplifier, which is a very common amplifier, well-known amplifier. So differential amplifier, you have here two inputs and two outputs. So the two inputs, Vn is input to this one and V input to this one, and you take the output at the common collector here. Yes. So you take the common emitter, so you take it from the collector here. Now you see here that the input here is reversed. Again, the input here is reversed. So this is differential mode input. It amplify the difference between the two input. Okay, so if you input the same signal here, this is reversed to this one. If you input the same signal, the output should be zero with common mode input here. Should be zero because it's amplify nothing here. Okay, to reject the common mode signals. If you input two signals as the same exactly common signals. but you see a signal output because of the noise. Here you see, usually you see some noise, you see some output because of the noise in the signal. So today I speak about characteristic parameter that include the R parameter, meaning that's including the beta, including the RE dash, RB dash, RC dash, alpha. So this is a characteristic of the BJT transistor. A common emitter, meaning that the BJT configuration and the emitter is terminal for the AC, so it's not connected to the input or the output. AC ground, meaning that the signal can appear in as a ground to the AC only. There is a point which, as I said before, we use the capacitance to prevent the DC from connected to out of the circuit. Input impedance or input resistance, the resistance that's seen by the AC source connected to the amplifier. The AC source, what is seeing from its point of view, the resistance that you see it. Now, yes, the output resistance is the AC resistance looking from the AC the amplifier output. Common collector, as I said, the collector is common to the AC signal. Differential amplifier is an amplifier that's the output is a function of the difference between the two input voltage. The common mode, meaning that a condition where two signals are applied to the differential input with the same phase and frequency and amplitude. Okay, so that's it for today. Thank you for listening.